All right, now we have 100% done this before, but always willing to do it again. Solving a quadratic equation by factoring. All right, now we just did this with graphing. All the names for a point that crosses the x-axis, x-intercept, 0, root, solution. There's probably more, but these are 4 I can think of. So I can physically see where this graph crosses the x-axis. All right, now x equals 0 and x equals 4. All right, now what happens if you take this equation and you set it equals 0? You get 0. What happens if you take this equation and set it equal to 0? You get 4. So if either one of these is a 0, okay, let's say I make x 0. Okay, 0 times anything is 0. Let's say I make the x of 4. Well, that's 0. And 0 times anything is 0. That leads us into, again, why it's called a 0, and this thing called the zero product property. If the product of two numbers is equal to 0, then each individual factor can equal 0. You saw that with the x equals 0 and the x minus 4 equals 0. The equation, key here, must equal 0 to use this property. Okay, so for example, like 5x equals 0, the x must be 0. But on a times b, if the a is 0, okay, well 0 times b is 0. What if the b was 0? A times 0 would still be 0. Then we've got w plus 13, w minus 9. If I set these equal to 0, let's say I plug in that negative 13. All right, so that's going to give me 0 times negative 22. Well, that's going to be 0. All right, so the point is you set your factors equal to 0. My other one would be 9. If I plug in a 9, that one's 0. This one's 22. 22 times 0 is 0. Okay, so we factor, get the equations equal 0, solve. All right, so these steps set the equation equal to 0. Okay, so if you have a y equals, I'm just changing the y to a 0. That's the point. It's an x-intercept, the y is a 0. And then I'm going to factor. 1 times negative 10. Factor pairs of negative 10. So they have to multiply to negative 10, but they have to add to 3. Okay, positive b, negative c. If you need to go back to your unit 5 notes, I think. Unit 6, maybe unit 6. I don't know. I'll find out. If you have a positive b, negative c, that's our little guy that's negative. And we see that one's the one that adds together to be 3. So we break this up. Minus 2x plus 5x. You're going to keep bringing down that 0. You're not going to do anything with it yet, but you're going to keep bringing it down. Group. GCF. GCF. That one is 5. Common binomial factor. And whatever is left. Right, using a 0 product, we set each of these equal to 0. That one you're going to add 2. And that one you're going to subtract 5. All right, get the equation to equal 0. So I'm going to change y to 0. multiply that. No GCF or anything on this one because it's x, 8x, and so on. So 1 times 16. Factor pairs of 16. All right, it has to multiply the 16, but it has to add to negative 8. So how is it possible to multiply and get positive and add to get negative? Because they are both negative. That's our factor pair. Group, no, last two. GCF for the first group. Your second group has a minus sign. So we want to bring that down. And that GCF is 4 as well. Negative 4x by negative 4 is positive x. 16 by negative 4 is negative 4. Common binomial. Whatever is left. So this is a repeated factor. So when it is repeated, you only have to solve it one time. Our x-intercept solution, root 0, is 4. All right, get the equation equals 0. Now this one does have a GCF. It looks like the GCF is 2x. And once I take that GCF out, I no longer have a quadratic right here. So I've actually done factoring, and we're going to set each of our factors equal to 0. 2x will equal 0. And 4x minus 3 will equal 0. So 2x will equal x is 0. We'll add 3. Divide by 4. So x equals 3/4. Keep the equation equal 0. All right, no GCF, but this is a difference of squares. Remember, difference of squares, even exponents. Take their square roots and you add them, subtract them. So x squared, 25, both squares. And you're subtracting them. Square root of x squared is x. 125 is 5. Add. And set the factors equal to 0. Add 5. X equals 5. All right, now every now and then you're getting an equation that doesn't even have a y. You still need to get it to equal 0 because that y is implied. Do it like in quotes. So, and to do that, I'm going to take away this 4x. Now, I don't have any like terms here. And that 4x is going to go in the middle. And when you subtract those, that gives me my 0. Now we factor. There's no GCF. Constant negative 45. Factor pairs. It's a negative b, negative c. So that's our big factor, negative. So it's got to multiply. It's a negative 45. Add. It's a negative 4. And I see that there. Break it up. That's why I wrote the 1 there. Group. GCF. GCF also have the negative sign. So that negative sign comes down. And that GCF is negative 9. So it's going to make negative 9x a positive x, and negative 45 a positive 5. Common binomial. Whatever is left. And since it asks you to solve, set those factors equal to 0. And solve them. Back to a y equals, so we're going to go ahead and put a 0 in. All right, this one has a GCF of 3. That's 4. All right, so factor. This time the leading coefficient is 1, because this 3 no longer counts as a leading coefficient once you factor it out. Times negative 4. Factor pairs are 1 and 4, 2 and 2. It's going to multiply to negative 4. Add to 3. Well, positive b, negative c is little guy negative. And there's my factor pair. Group. GCF for the first group. GCF for the second group. Also leading up to plus, so I'm going to bring down a plus. Common binomial. Whatever. And your GCF. All right, to have a solution, your factor must have a variable. I say that because it is a factor, but it doesn't have a variable. It has no solution. Okay, but I do have my x minus 1. That's a factor, and it has a variable. We'd add the 1. Same thing with the x plus 4. It's a factor, and it also has a variable. So those are my two solutions. Okay, equals y, so we need it to equal 0. We'll put the 8 by the 5. Factor pairs of 40. All right, this time because your leading coefficient is 8, has to multiply to AC. That's 40. Still needs to add to negative 22. Okay, so how is it possible to get positive when you multiply but negative when you add if both are negative? And I can see right there, it's the one that adds to be negative 22. So break it up. Group, sorry, and then GCF. GCF for the first group, 2x. GCF for the second group, and negative. Negative. Common binomial. Whatever is left. And solve. If it has a variable, it has a solution. Do the same thing with your 2x minus 5. Those are our two solutions. All right, this says f of x, which is really just fancy y. You're still going to set it equals 0. Multiply 5 by 3. No GCF because 5, 8, and 3 don't share anything. Let's see. Factor pairs. There's only those. This one, because of the A being not a 1, we have to multiply to AC. In this case, that's 15. And it has to add to negative 8. So both factors negative. And I can see it right there. Group. GCF. GCF. And negative. Take out that negative 1. Common binomial. Whatever is left. Set those factors equal to 0. Remember, if it has a variable, it has a solution. Divide by 5. X equals 3/5. And we have our x minus 1. X equals 1. All right, last one. You see no y's in here, but the equation also doesn't equal 0. We can see that. So I'm going to subtract the x squared. 4x squared plus 7x. I also need to subtract the 2. All right, no GCF because of the 7. And multiply 4 by negative 2. Factor pairs. So because of the 4, we know it has to multiply to AC, in this case negative 8, but add to positive 7. And the way that happens is if the little guy is the one that's negative. Break it up. Group. GCF. GCF. And it's positive. Common binomial. Whatever is left. If it's got a variable, it has a solution. Set that equal to 0. So add your 1. Divide by 4. Set that one equal to 0 as well. Subtract 2. So it should be a pretty good review of all the factoring that we've done from units 5, I don't even know what unit we're on, 6, 7, 8, who knows. Here we are.